Yo, what is up, guys, and welcome to another lesson. In this lesson, we are going to cover the theory on decimal numbers. We will discuss what is a decimal number and the different types of decimal numbers there is. Without any further ado, let's jump right into it. We can write any rational number as a decimal number. Remember that a rational number is any number that can be written as a over b, where a and b are integers and b cannot be 0, because any number divided by 0 is undefined. But not all decimal numbers are rational numbers. These types of decimal numbers that I'm about to teach you are rational numbers. Decimal numbers that end or terminate. For example, the fraction 4 over 10 can be written as 0,4, or 1 over 2 can be written as 0,5. These are decimal numbers that end. As you can see, 0,4, that's where it ends, or 0,5, and that's where it ends. In our future video, we will learn how to convert these decimal numbers to fractions and vice versa. Another type of a decimal number are decimal numbers that have a repeating single digit. For example, the fraction 1 over 3 can be written as 0,3 with a dot on top, or 0,3 with a bar. The dot and the bar notation mean the same thing. You can use either both, and both represent recurring threes. These threes, i.e. 0,3 dot is the same thing as 0,3 bar, and is the same thing as 0,33333. They don't end. We will also learn how to convert decimal numbers that have a repeating single digit in our future videos. And the other type of decimal number are the decimal numbers that have a recurring pattern of multiple digits. For example, the fraction 3 over 11 can also be written as 0,18 bar, or you can use the dot. The bar represents a recurring pattern of 1s and 8, i.e. 0,8 bar can be written as 0,181818. This is what they mean when they say recurring pattern of multiple digits. We will also learn how to convert these decimals that have a recurring pattern of multiple digits into fractions. Now let's do a mini quiz to test what we have learned. Now determine if the following number is a rational number or irrational number. You can pause the video and then try these examples on your own, and then unpause to see the solution. So number 1, is pi a rational or irrational number? Before I answer this question, I want to teach you a trick. If you are asked to identify whether a number is a rational or irrational, write the number in decimal form. If the number terminates, then it is rational. If it goes on forever, then look for a repeated pattern of digits. If there is no repeated pattern, then the number is irrational. So let's look at pi again. Well, pi is irrational because the decimals do not terminate or end. They go on and on and on forever. And it has no repeated pattern. As you can see, 1415926, there is no pattern. So therefore the number is irrational. What about 1,4? Well, 1,4 is rational because the decimal terminates or it ends. So this one is rational. This one was irrational. What about the third number? The third number is also irrational because the decimal does not terminate, it does not end because of this dot, so it goes on forever, and it has no repeated patterns. As you can see, 6, 1, 8, 0, 3, 3, 9, 8, what. So therefore this one is irrational. What about 100? 100 is a rational number because all integers are rational. And what about number 5? Number 5 is also a rational number because the decimals have a repeated pattern. As you can see, 7373737373, therefore rational. And what about the 6th example? Well, it is also rational because the decimal has a repeated pattern. How do we know that? Because of the bar here. Therefore, this number is also rational. I hope you enjoyed the lesson. If you have any questions, leave a comment. I have no life, so I'm probably going to answer all your comments. If you liked the video, please subscribe to my channel, share the lesson with your friends, and turn on your notification bell so you do not miss when I post another lesson. Thanks for watching, and I'll catch you in the next one.